I'm Kishore, a student at Ramaya University of Applied Sciences, pursuing a degree in Electronics and Communication Engineering. I'm here to provide an overview of our current module and the assignment we are working on. First, let me provide an overview of this module we are currently studying. Let's consider Saptagiri College of Engineering as an example. This module focuses on data analysis and visualization in the field of engineering education. We are tasked with analyzing and visualizing the trends in the cutoff ranks for different branches at Saptagiri College over a span of 8 years from 2016 to 2023. The aim is to gain insight into how the popularity competitiveness of these branches has evolved over time. In this assignment, we are expected to perform the following tasks. First, collect the data of cutoff ranks in the general merit category for the year 2016 to 2023. Next, visualize the distribution of cutoff ranks for each branch, ECE, CSE, and MEC to understand the general trends. Next, fit a straight line to the data of each branch, which helps in identifying trends and predicting future cutoff ranks. Next, after completing this task, we will analyze the trends in each branch. The structure of code. Uh, in this code, we are going to analyze and visualize the cutoff ranks for different branches at Saptagiri College of Engineering from 2016 to 2023. Firstly, we import the necessary libraries that will help us with data analysis and visualization. We import matplotlib for plotting, numpy for array manipulation, and linear regression from sklearn for fitting linear regression model. Next, we define the data for different year and branches. We have years from 2016 to 2023 and corresponding cutoff ranks for the three branches ECE, CSE, and MEC. Let's move on to our first task, which is to visualize the distribution of cutoff ranks for each branch. We create a figure with subplots for each branch to provide clear visualization. The plt.plot function is used to plot the data points and labels, titles, legends are set for each subplot. Our second task is to fit a linear regression model to the data for each branch, allowing us to identify trends and patterns. We define a function fit and plot for this purpose. Inside a function, we create a linear regression model, fit it to the data, and generate predictions. Afterward, we create a new figure and plot the actual data points and the linear fit. This step helps us to visualize the trend. Next, we call the fit and plot function for each branch ECE, CSE, and MEC. This allows us to analyze and visualize the trends in cutoff ranks for each branch individually. Let's run the code. I'm using here Google Colab to run this code. If we run, we'll get a graph. In conclusion, we can say that this code provides a structured approach to analyze and visualize data trends for different branches over the specified years. This code structure allows to collect, visualize, and analyze the data for three branches ECE, CSE, and MEC by fitting linear regression model to understand trends over the years. Now we will explore a Python that automates the extraction of cutoff ranks for educational institutions. This allows us to quickly retrieve cutoff ranks data based on specified parameters. Let's dive in. Code overview. Our code consists of stimulated cutoff rank data and a function to extract this data. Let's take a look at the structure. Cutoff data. We start with a dictionary named cutoff data containing stimulated cutoff data for multiple colleges, branches, and years. This structure helps organize and stimulates the data. Next, g- next def get cutoff rank. Next, this function takes college code category, branch, and year as parameters and attempts to extract the cutoff rank from our stimulated data. If we Let's see this in action with an example. I'll run the code with the parameters. I'll enter the college code as E108, category as general merit, branch ECE, and the year we can give as 2018 or any other year. Now, the code successfully found the corresponding cutoff ranks in the stimulated data and displayed the result. The output will vary based on the input and the availability of data in the cutoff data dictionary. If the data is not found for the specific parameters, the code will print data not found for the specific parameter. Next, we'll dwell into a Python that creates a scatter plot of cutoff ranks for different branches over multiple years. This can be valuable tool for visualizing trends in admission criteria. Let's jump right in. The code overview now begins by simulating cutoff ranks data for various branches. Will then prompt the user to input details such as the college code, category, and branch. Uh, if the provided branch exists, and if so, proceeds to create a scatter plot using matplotlib. Next, simulated cutoff rank data. Take a look at the simulated cutoff rank data. We have information for branches like electronics and communication, ECE, computer science, CSE, and mechanical mech across different years. This is the data we'll be visualizing. If we run the code with the inputs, college code as E108, category general merit, branch we can take ECE. Here's the output. We have successfully created a scatter plot showing the cutoff ranks for selected branch over the provided years. This visual representation can be invaluable for identifying trends in admission criteria. We are going to enhance our cutoff ranks visualization script by adding a linear regression analysis. Here's the code. We still have stimulated cutoff ranks data for various colleges. This time we are adding an extra layer of analysis by fitting a linear regression line to the data points. Prompted to enter college code, category, branch, just like before. If the entire data is available, we'll proceed to perform linear regression and visualize the results. Now we'll run the code with inputs, college code as E108, category general merit, branch we can take various branch like CSE, ECE. I'm taking here as mech. Here's the output. We have successfully added a linear regression line to our scatter plot. The red line represents the trend in cutoff ranks over the years. The slope M and intercept B provide insights into this trend. Thank you. Modules and libraries used and their needs. Here's a more concise way to explain the modules and libraries used in our code and their needs. Firstly, the matplotlib. The purpose of the matplotlib is used for data visualization, allowing us to create charts and graphs. The need of matplotlib is it's essential for visualizing cutoff ranks, making data trends more accessible and enhancing communication. Next, NumPy. The purpose of NumPy simplifies numerical computing and offers support for arrays and mathematical functions. The need of NumPy is we use NumPy to manipulate data, making it easier to work with arrays and perform data reshaping. Level of automation in the code. In this video, we will develop into the level of automation achieved in the code that we have been working on. Firstly, the data collection. Let's start with the data collection process. In our code, data is manually input as static value. While this gets the job done, it requires human intervention to update the data. Next, the data visualization. Moving on to data visualization, the code does a great job of automatically creating visualizations for cutoff ranks. However, there's still some manual configuration involved in formatting the plots. Next, linear regression analysis. Now, when it comes to linear regression analysis, the code shines. It fully automates the process of fitting linear regression models and generating predictions. Next, conclusion and analysis. In this, however, the code falls short when it comes to automating the analysis and commentary on trends. This part is left for manual input and is not automated.